This is one type of problem that's going to require a rational equation to solve. And it says Kaylin takes 4 hours to paint a room. It takes Cavani 3 hours to paint the same room. How long will the paint job take if they work together? This is a typical type question where you're dividing the work. And so basically what we need to do is look at what fraction of the work is going to be done by each of the workers. We still need to go through that process of solving a word problem. So the first step should be defining the variables or variable. What's the variable here? The hours that it takes in total, right? The amount of time that it takes them to paint together. So we'll start with that. And I'm going to use T. You can use whatever letter you want. Time to paint together. So that's what we'll say T is. T is the time it takes them to paint when they're working together. And then we need to divide that time up. So the way it's going to work, if you take that time and divide it by 4, that's the amount of work, that's the fraction of the job that Kaylin's going to do. And then we need the fraction of the job that Cavani's going to do. And what should we divide the time by for her? 3. And that equals the total job, so 1. So that was the first step, define the variable. Second step, write the equation. Third step, solve. And this is a really easy rational equation to solve, right? We don't have to factor. We don't have to come up with a complicated denominator. What's the common denominator? 12. So we need to multiply each thing by 12, or by 4 times 3. So we'll go times 4 and times 3, which is 12, times 4 and times 3, times 4 and times 3. But what happens, right? The denominators cancel out. The 4's are gone there, so we have 3t plus, here the 3's cancel out, so we have 4t equals 1 times 4 times 3, which is 12. And then combine terms, 7t equals 12. Divide by 7. T is equal to 12 over 7. Or 1.7 hours. Now, I always tell you to leave your answers as fractions, right? But 12 over 7 doesn't really mean anything in the context of this problem. We want to know how long is it going to take them? It's going to take 1.7 hours. You wouldn't say it's going to take 12 over 7 hours. That just doesn't make sense for this question. So we will, and that's rounded. It's 1.714285 repeating. But we'll leave it as 1.7 hours. So what's the last step? Check. So we could fill in 1.7. And when I fill in 1.7 divided by 4 plus 1.7 divided by 3, it equals 0.99, which is close to 1. I had a rounded answer, so I'm going to have a rounded answer here. It's not going to be exactly 1. But if you actually fill in 12 over 7, it'll come out to exactly 1. So we check that way. Does that answer make sense? Yeah. We knew it was going to be less than 3. A pretty good guess was 2. 1.7 is close to that. So you kind of, when you're doing this kind of problem, need to think too, does your answer seem reasonable? If you came up with like 17 hours, you should stop and go, that doesn't make any sense. But 1.7, that makes sense. And then what's the last step? Very last step when you're solving a word problem? Yep, the answer statement. So we'll say it takes them 1.7 hours working together, or something along those lines. This one is a little different, but it's still going to be rational. It says the sum of two numbers is 12. The sum of their reciprocals is 3 over 8. What are the numbers? N is one of the numbers. I'll just call it the first number. So then we need something for the second number. And you do have two choices here how you want to do this. You could use a completely different variable like m, but then you'd have to write two equations to solve a system, or you could say 12 minus n, right? Remember we did this with quadratics too, right? If the sum of the two numbers is 12 and one of them is n, then the other one is 12 minus n. And then it says the sum of their reciprocals is 3 over 8. We need to write an equation. The reciprocal of n is 1 over n. What's the reciprocal of the second number? 1 over 12 minus n. And it says that the sum of their reciprocal. So how can I make that a sum? Plus equals 3 over 8. Right. Okay. Now we need to solve that. What's the common denominator? N times 12 minus n times 8. That's the common denominator. That's an 8. Can't tell, but that's an 8. Right? You just take each factor from the denominator, and there's no factoring to do, so we just take each denominator. None of them are the same. They don't have any common factors. So for the first one, we'll cancel out the n's, and it becomes 1 times 12 minus n times 8. And then the second one, we cancel out the 12 minus n. So it's 1 times n times 8. And the last one, we cancel out the 8. So it's 3 times n times 12 minus n. This looks like it's going to be quadratic, isn't it? Expand and simplify. So 12 times 8, 96, negative n times 8, minus 8n, plus 8n equals 36n minus 3n squared. Move everything to one side. Because it's quadratic, that's how we solve. Make one side equal to 0. So I'm going to take the stuff on the right and move it over to the left so that that squared term is positive. I don't like having my lead coefficient negative. So I'll add 3n squared, and I'll subtract 36n. Negative 8n and positive 8n, those cancel each other out. Plus 96 equals 0. So to solve it, we factor, take out a 3. N squared minus 12n plus 32. Can we factor that? N minus 8. N minus 4. Does that look right? So this says n equals 8 and n equals 4. And what that means is that the first number could either be 8 or 4. If the first number is 8, what's the second number? 4. And if the first number is 4, the second number is 8. So those are actually the two answers. It doesn't always work that way, but we can then say the numbers are 8 and 4. And we could check, is the sum of the reciprocals 3 over 8? 1 over 8. Yes. Charlene drove 404 kilometers from Edmonton to Banff in the same length of time that it took Raphael to drive 364 kilometers from Edmonton to Jasper. So they were driving different distances, but it took them the same length of time. Charlene drove 10 kilometers faster than Raphael. What speed did Raphael drive? So first thing we're going to think about is what will our variable be? What will it represent?
X.
I don't really care what letter you use, but I do care what it's representing. What are we trying to find in this problem? Whose speed?
Raphael's.
Raphael's speed. Then that's going to be our variable. So first step, I'm just going to use X. That should say speed. That didn't help. So that says X equals Raphael's speed. I should probably type that. When I have this type of problem, I always organize my information into a chart, and it really makes it so much easier to solve. So the two rows of the chart are going to be either two people or two places or two trains, depending on what the problem is. In this case, my two rows, oops, I spelled that wrong.
You should get a stylus, Miss Burns.
So we have the two names, and then we have three different things that we want to look at, and they're always going to be the same three things. Their distance, time, and speed. And when you have this type of problem, here's how it's going to work. We're going to fill one of the columns in just with numbers, and you'll always have that in the problem, some numbers that you can fill one of those columns in with. Which column, distance, time, or speed, can we fill in with numbers? Distance, right. Because Charlene, distance, 404. Raphael, distance, 364.
No.
Another column gets filled in with variables. Which column are we going to fill in with variables? Speed, right. Yeah. So we'll do Raphael's speed is X and Charlene's is X plus 10 because she drove 10 kilometers per hour faster. So there's two columns filled in, one with numbers, one with variables. The third column we fill in based on the relationship between distance, time, and speed. So here's what I know. Okay, reset. I know that speed is equal to distance over time. Did you guys know that? We can take that little speed equals distance over time and rearrange it to get time is equal to distance over speed. And so the third column I'm going to fill in using the fact that time, because it's the time column, is equal to distance over speed. So Charlene's time, 404 over her speed, which is X plus 10. What's Raphael's time? 364 over X, right. This I'm going to use along with a piece of information from the problem to write an equation. Right, that's the piece of information we haven't used yet, right? Is that their times are equal. It says that Charlene drove from Edmonton to Banff in the same length of time that it took Raphael to drive. And so what that means in terms of the equation is that Charlene's time, which is 404 over X plus 10, is equal to what? Right, 364 over X. And then we can solve it. So the solving part is the easy part now. Multiply both of them by X times X plus 10. We end up with those canceling and those canceling. 404X is equal to 364 times X plus 10. expand. And then I'll move the 364 over. I get 40x is equal to 3,640. This is nice because it's just linear. And I end up with x equals 91. I do need to consider non-permissible values, but that's not one of the non-permissible values, so we're good. Does the answer seem reasonable? It's the speed in kilometers per hour, right? 91. Maybe she drives a little fast, but Charlene drives faster. So, the question was, at what speed did Raphael drive? She drove at 91 kilometers per hour.
Look it up. Is it?